Hello, everyone. Thank you for joining us today as we come together to learn more about starting the serverless journey with Azure Functions. My name is Hassan Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. All right, our speaker today is Firas Mdimagh. Firas is a Cloud and DevOps enthusiast. He assists businesses in moving forward with their digital transformation. In his current role, he enjoys being an Azure Technical Trainer at Microsoft, helping customers to realize their potential through building their team technical capacity. Firas was also a Microsoft MVP for 2 years in 2018 and 2019. Feel free to ask questions during this session. We will have regular stops to answer your questions, and also feel free to tweet about the session and tag us on Reactor Abu Dhabi and MSFT Reactor. That's the Twitter handle. And you can adjust the playback settings to select the highest quality for the best experience in today's sessions. And yeah, with all that said, I would like to hand over the mic to our speaker to start today's session.
Thank you, Hussam. Can you hear me?
Yes.
Great. I'll just share my screen. So thank you, Hassan, for presentation and the invitation. And thank you all for attending this session today. It's all about serverless. It's all about Microsoft Azure and the service Azure Functions. So like Hussam said, I'm an Azure Technical Trainer at Microsoft. Before I was a software engineer and Cloud and DevOps consultant. And Microsoft MVP. I have used Microsoft certificates such as Azure Fundamentals, Administrator, Developer, and DevOps Engineer Expert. So during the session of today, we'll see what is serverless. In general, we'll see some services in Azure that are part of this type, and we'll talk about Azure functions and orchestration of Azure functions with what we call durable functions, and we'll end the session by Q&A and your feedback, of course. So before starting, I want to ask you a few questions via menti.com. So you can go to menti.com and use the code 6437044. So there are 3 questions. We'll start with the first one. What is your job title? Menti.com. The code is 6437044. Hussam shared that on the chat window. STS, analyst, structure lead, consultant, data engineer. Okay, so I put data engineer, dev. Okay, great. Okay. Okay, Second question, have you worked before with cloud platforms in general, Azure, AWS, GCP, IBM, etc.? Yes, no, 5%, okay. Great. And have you worked with Azure before? Microsoft Azure, the cloud platform of Microsoft? Yes. Okay. Great, thank you. So, like I said, we start our session with what is serverless in general, serverless in Azure. Then we'll discuss Azure Functions and the extension durable functions, and we'll finish the session by your questions and a quick survey. So, to start, what is serverless? So, serverless is the abstraction of servers. There are always a server, but it's an abstraction. It's an event-driven, an instant scale in the most of the case. So what we need to do here today with serverless is we don't care about the infrastructure. It's an abstraction of the infrastructure and all the servers. It's an event-driven, so it's based on events. On input and on output. That's what we see in Azure Functions. And the thing also is micro billing. So we pay what we consume, or is the model of the cloud in general, pay as you go. It's the same thing. All this definition is the same, and we found it in Microsoft Azure, in the cloud platform of Microsoft Azure, and we have many services that are part of this type. We have Event Grid, which is a service that help us manage all events that can trigger code or logic. So Event Grid we can use with our applications, with our custom applications, or we can find it also integrated natively in Microsoft Azure with many services. For example, when we use the storage account in Azure, we found that Event Grid is integrated natively, and we can use it with Azure Functions or other services also. The second service is Logic Apps. Logic Apps help us design workflows and orchestrate processes. It's based on the FTT, if this then that, is the same as Microsoft Flow, or the new one, the Microsoft platform, or the Power Platform, sorry, Automate. And it is integrated with Microsoft services, with Office 365 services, and also with enterprise services and application. And we can also add our custom connectors. And the third service is Azure Functions. That's what we'll discuss later. And Azure Functions help us execute code based on events that we specify at the beginning. So we'll talk about Azure Functions during this session, and we'll see what we have in this service. So to start, Azure Functions is based on code and events. What does it mean? So we have our code. We don't care about the infrastructure. It's handled, it's managed by Azure, and we'll just push our code to Azure, to the Azure function. And from the other side, also there are the events. So it's based on code and events, and this is for information, the logo, the official logo of Azure Functions. Azure Functions supports a lot of languages. So there are programming languages such as C# or F# with .NET platform, Java, PHP, Python, and JavaScript. And there are also the scripting languages such as PowerShell, and the announcement was one of the best announcements about Azure Functions for DevOps teams or CloudOps teams. So Azure Functions is based on events and code, and also we found two keys. We have triggers and bindings. The triggers, we use it to execute our functions, to say we need to run our functions at this time or at this action. And we have also what we call binding. So we run our function and we need to have the binding or the link with other sources. So a trigger defines how a function is invoked at the beginning. A function must have exactly one trigger, one only trigger. And triggers can have associated data, which is usually the payload that triggers the function. And we have also, like I said, the bindings, and we have two directions, the input and the output. So the input can be integrated directly with the trigger. So input and that output bindings provide a declarative way to connect to data from within the code directly, and bindings are optional in our function, but we can have it, and most of the time we have at least one binding. And an Azure function can have multiple input and output bindings. The input bindings can be integrated with the trigger directly, or we can have another binding, another connection with another Azure service directly. Same thing for the output. We can have one or many output bindings for the same thing for Azure sources or for other sources. So in general, we have this simple architecture with Azure Functions, a trigger and one or many bindings. And we have, of course, our code here in our function app. We have a lot of triggers and bindings. We have the basic triggers like the HTTP, so from the input or the trigger, HTTP trigger, and we have also the timer. So those are the basic triggers. But we have other triggers that are integrated directly with Azure sources, such as blob storage. So blob storage is an Azure services. Within these servers, we can use other subservices like the table, like blob storage directly, like for example queue. And this kind of service, the blob storage in the storage account service, we can manage our blobs, our files. So when we use this trigger, we can say that when we upload a file to the storage account, to the blob storage, we will trigger our function. Same for Cosmos DB, same for Event Hub, for the queues, and for Service Bus also. For the bindings, it's the same thing. We have our link or our connection with other sources such as file, table, or other external sources such as Excel, OneDrive, email, mobile app, etc. And we have the HTTP also. If we have the HTTP request, most of the time we will have our HTTP response after that as a response. So this is in general what we have with functions. We have code, we have events, we have triggers, we have bindings. Best practices for using Azure Functions are, first, we need to avoid long-running functions. So functions are limited, and there are timeouts between 5 and 10 minutes. It depends on our configuration. And functions that run for a long time can time out. So be careful about that. Second thing is that we need to use queues for cross-function communication. And if we need to have a direct communication, there are few solutions for that, such as Azure Logic Apps, which is another Azure service, or we can use the extension of Azure Function, which is durable functions. We need also to write stateless functions. Functions should be stateless and ID dependent, and state data should be associated with the input and output payloads. And finally, we need to code defensively. We need to assume that the function might need to continue from a previous fail point, which is not handled natively with the function. So we need to make sure that our code can handle that via the queues or via other sources in Azure. And there is also an extension for the functions. Like we said, if we need to have a direct communication, we can use durable function, and durable functions help us write stateful functions in a stateless environment. And we can manage state, checkpoints, and restart with this extension. And you can also define an orchestrator function, a workflow from A to Z, a function that call another function, a checkpoint progress whenever the function waits, and finally, durable functions, like I said, is an extension of Azure Functions that lets you write stateful functions in a serverless environment. We have a lot of scenarios or a lot of patterns inside durable functions. We have the chaining, which is the basic one or the simplest one. It's a sequential state of functions. What we have here is the function chaining that refers to executing a sequence of functions in a particular order. Often the output of one function is the input of the other functions. For example, here we have the function f1, and the output here of the first function, which is f1, is the input of the second function, which is f2. And finally, we can have the last here output, which is from the f4. Another also scenario or pattern is the fanout finding. It's the same thing. It's used via durable functions, but here what we have a pattern of executing multiple functions in parallel and then waiting for all to finish. So here it's like the batch operations. We have the f1, the first function that will trigger or launch the second function, but many instances of the second functions or many operations of the second function. And then the output of all the operations here will be the input of the last function here, another operation maybe, and then we can have the output or the final output, the result of all this process. So there are other patterns, there are other also here scenarios that we can use with durable functions. So this is quick presentation about Azure Functions and durable functions. Let's see what we have really inside Microsoft Azure. So for those who didn't use Azure before, or the Azure platform before, to use Azure, we need to go to portal.azure.com to manage our sources. And here we can manage the sources. We can create, update, and delete if we don't need the sources anymore. So what we can use here, what we can do, here, we can create the sources. We can, for information, we can create the sources via the portal, via the scripts, like, for example, PowerShell or Azure CLI, or we can also use the Azure API also. So in this demo, we'll create an Azure function, what we call an Azure app via the Azure portal. So what we can do is just click on create a resource, or also search for function. Here we can create our function app. And to create the function app, we need to have, or to create a service in Azure, we need to have a subscription. So here we need to select the subscription, and we need also to select the resource group. So the resource group is a logical group of services inside Azure. So we have what we call service or also a resource. We create our resource group while we create the service in this case, or we can create also the resource group before creating the service inside Azure. So here, let's say it's Reactor, Azure Reactor here, fine. And then we need to add the details about our function app. So when we create a function app in Azure, we'll create an app or a function that is a subdomain of Azure Websites.net. So here, for example, you can say function Reactor fits. Okay, it's used, need to be unique. So here we can say it's demo, fun Reactor demo. And then we need to select the publish mode. It can be code, or it can be also a Docker container. The Docker container right now is not supported in the serverless side. We'll see that in the next step. So we'll select code, and then we need to select the runtime stack. It can be .NET Core, Node.js, Python, etc. We'll select .NET Core. We need to select the version. Here we have the latest version of .NET Core, which is 3.1, and we need also to select region, which is the same thing for most of the Azure services. We need to select region where we will create the instance or the current instance of this function app. Let's select, for example, Europe. And in the second step, we have the hosting. So when we will create a function app, we need a storage account. A storage account is here for the Azure function, to be used for a general purpose. For example, for the function code that will be uploaded later, for the events that will be created or generated by the Azure Functions also. And then we need also to choose our operating system. Azure Functions supports Linux and Windows also. And finally, we need to select the plan. So here in the Azure Function service, we have three types or three plans. We have this consumptions, which is serverless. We have the premium plan and the app service plan. The app service plan is like the web apps in Azure. It's the same infrastructure finally. And we have the premium one, which is based on serverless, but we have other features like networking and also management inside our environment in Azure. So we select simplest one, consumption. It's serverless. We are here to talk about serverless, and then we can also activate or enable or disable the application insights. Application insights is another service in Azure. It is used with web applications or applications in general to monitor them, and it's the same thing here in our function app. We'll enable it, and we'll create another instance of the server in order to monitor our functions here. Then we have the tags, don't need them right now, and finally we need to review and create. So we'll create our function app, and we'll see what we have. So here we will create at least 4 services in Azure. We have our function app, we have the storage account, we have application insights, and we have also what we call an app service plan. So we select consumption, but there is an infrastructure behind that is managed by Azure, but we need at least the reference for this service that will be created. So what we will create after we create our function app here inside Azure. So here what we have Azure, and we're creating an instance of our function app here. And inside this function app or inside this service, we can add or we can publish many functions. So what we'll do, we'll for example publish 2 functions. So func 1 and function 2. This is what we'll be doing right now. So from a developer side, when we'll develop and publish the functions, we have many solutions. So first thing first is managing all of these functions inside Azure directly from the portal, and we have this possibility. Here, after creating the function app, we have the list of our functions here. So we can develop directly inside the portal, or we can also publish the functions from another platform that supports DevOps, or we can develop and publish locally, for example, from Visual Studio, Visual Studio Code, or other IDE. So we start by developing or by creating our function directly inside Azure. Here we have many templates. We have, for example, the HTTP trigger. So it's an HTTP trigger function, or the time trigger function, Azure queue, storage, or other triggers and other bindings with other services inside Azure directly. we'll create an HTTP trigger function, the simplest one here. We need to add the name of the function and then the authorization level. We have 3 authorization levels. So we have the function, anonymous or admin. Anonymous, it's an anonymous function. Anyone that has the link will have access to this function. The function and admin levels need to have or to use a key. We have 2 types of keys. We have the function and the admin. The function key is related to the function or the functions, it depends on the level, and the admin, the key for the admin can be used to access the functions, but also to access some administrative APIs for management here inside the function. So to start, we'll select anonymous and then click on create function. Here, a function is created with the name of HTTP triggers, and that will be anonymous also. So here is our function. So what we're creating here, just to be clear, here we are in Azure, we are the Azure portal. We created our function app, and what we just did here is create the HTTP trigger. We created a function called HTTP trigger. And the function contains the code. So we said that the function is composed of code and events, trigger and bindings. So here we can access the code since we created the function directly from the portal. And here, for example, we selected .NET at the beginning, so it's C# and we have our function. It's a simple function here. It's based on the HTTP trigger. So we'll have an HTTP request at the beginning, and then as an output, as a result, we'll send an HTTP response then. So here it's a simple function. We'll need the name, and then we'll send the response saying hello name, for example, or if there is no name, we'll send a message saying that we need the name as an input. So here is our simple function. We can test it and we can run it directly from the portal. Also, we can select the method here, get or post, and then we can use the key to simulate the execution of this function. And we have also the query, the headers, and the body directly. We click run, and then we need to wait for the output. The output is simple. The response code here is 200. It's okay. It was run successfully. And here, hello Azure, this HTTP triggered function executed successfully. This is, like I said, a simple function. What we can do here is access the run.csx here directly on the portal. We can also access the function .json. So here we're adding the bindings, and it's a declarative way here to manage the binding. So here we have the authentication level, which is anonymous. The name of the parameter here, request. The type is an HTTP trigger, and in this case we have also the binding directly, and we can also select the methods get and post. The direction here, it's input, and the second binding here, the direction is output, and it's HTTP also, so it's an HTTP response. We can update this file. We can say here it's function, so we need a key to use it, and here we can say that we will use only get, and we can click on save. We can go back to our run.csx here, and you can test it again. So here, if we test it with post, like that, need just to refresh. So here we need to test it with get, sorry, and with get, so we can test it directly like that. And we need to pass a name. What we can do here is get the function URL here and test it in another window. So here it's funcreactordemo.azurewebsites.net/API/ the name of the function, which is HTTP trigger, and here we need to pass a name. We can pass here the name directly, and everything is okay. But what we want to do is here, sorry, I think, yeah, it wasn't saved, sorry. So here, function, I need to save it here, okay. And now, if we will do the same thing in the window, so here we have an error, because here our function is protected and we need a key. Like I said, we have two types of keys. Here we have function keys, and we need to have or to use these keys. There are always default keys, or we can also add our key directly here, and it will be generated by our function app. So here we're on the function level, and we generated a key, and we can use this key directly. To use this key, we can append it here. You can say it's code equal what we have here, and we have our response here, hello Reactor. So this is one of the security concepts that we can have inside Azure Functions directly. Like I said, here there is the function key, there is the function level key, but there are also the function app level keys. So here we are in the function app level, and we have also the app keys, what we call here the host keys. And if we use one of these keys, so we have the master or the admin key and the other keys, the default key. If you use those keys, we can use it with all the functions inside this function app. But if we use the key here in the function key, it's also meant to be used with this function only. We have also, so this is the code and test part. We have the integration also part. The integration here is a UI of what we have inside our function directly. So for us, it was an HTTP trigger. We have our function, and as an output, we have our HTTP response. But we can update it if we need to add some bindings, and we have the list of bindings: blob storage, Cosmos DB, table, client orchestration, etc. This is from the input side, and for the output is the same thing. We have many other binding types here. So this is the first part. We developed our functions directly from the portal. What we can do also here is develop our functions locally and then publish it directly to the Azure platform or via DevOps platform like GitHub, Azure DevOps, or other platforms. So what we can do here, we can also use Visual Studio, for example. Let's use it at the beginning. So here I have Visual Studio. To use the functions, we need to have the function runtime installed in our machine. If you have already installed the Azure development inside Visual Studio directly, so the Azure function runtime is already installed. And here we can create a new project. So here, just to show you how to install it. So we need to install the Azure development here inside Visual Studio, and click on Create Project, and we'll have the templates here. So here we can search for function, and here we have the template of the function. Click on Next. We need to add a name. Reactor, for example, function app, and then create. Here we have the templates. To start, we have 3 versions of the other Azure functions. So version 1, 2, and 3. For example, for .NET, for the version 1 is .NET Framework only. For version 2 and version 3, it's .NET Core. For version 2 is .NET Core 2. For version 3, it's .NET Core 3. And here we have also the template of the function. You can say that it's an empty function app. So here we're creating the project. The project is like a function app inside Azure. And then we can add our functions directly. So here we have our function, and we have our project here with no functions inside. We can add our function. Click here on Add, new Azure function, and here we can directly add the Azure function. Then Visual Studio will ask us about which template we need to use, HTTP trigger, timer, queue, or another template. We will say that we'll develop an HTTP trigger and the authorization level, for example, function. Click on OK, and we have almost the same function that we had on the portal. It's the same thing. We need to have on input the name, and the output is hello the name. So here we have everything. For example, in .NET, everything is here. Everything is inside the code. What I mean by everything is the attributes here. For example, the function name. We can here change the function name. After that, we have also here the trigger. So we can have HTTP trigger or timer trigger directly, or we can install also another triggers via other libraries like the queue, or like the table, or etc. And here we have also the authentication level that can be function, anonymous, or other. And we can update it also. Here we can say that we'll use only get, and we can also have the route. So here, like we said at the beginning, we have here /API/the name of the function. We can say that here it will be / for example, reactor / the name of the function. So we can do it here, and we can say that this reactor. So here we have /API/reactor / the name here reactor function, and then we have our function. What we can do here, since we're developing locally, we can run this function locally directly here. Since we installed already the Azure Functions runtime, and here we have our function that is being executed directly inside our machine. So here we're creating the function, and we're running the function, and then we'll have the link to test this function locally. So here we have the link to test our function, and we can use it directly here. So it's /API/reactor here, and we need to have the name. So here name equal, for example, Azure, and hello Azure is the same function. What we can do also here is publish directly. So this is not the best practice, but we can do it. So we can here publish directly to Azure. So we click here on publish, and then it's the same process inside Visual Studio. So we can select function app, and we can use our credentials, our account that is being used with the Azure account. But what we can do also is, if for example we have if you don't have the account or have another problem, so what we can use the import profile. So here it's like the classic apps or the classic web apps. We have here on the overview of the function app, we have get publish profile, and we can download directly here the publish profile. And then here we can click on import profile. We can use this profile, and then desktop profile, and we can use. So here we're creating connection between our machine or this instance of Visual Studio and Azure in order to publish this function directly. We can click on publish, and here we're publishing our function directly to Microsoft Azure. So here we've already developed the function inside from the portal, which is called the HTTP trigger, and then we developed another function locally, and then we're pushing this function to Azure. So here what we're doing is overwriting the existing function or functions inside the portal directly, because inside the function app we can have only one or another. We can have the functions developed from the portal, or the functions developed locally or published from Visual Studio or another platform directly. So here we can see that everything is okay. we can click on refresh here. And here we need to have our function reactor directly. So the first step is deleting, yes, the first step is deleting the other function that was developed via the portal, and then push or publish this function. So here we have the function, but here, since we have developed the function locally, we don't have access to the code. So it's precompiled and published directly to Azure. But here we have only the function app that is generated based on what we have mentioned in our code here directly. So here we said it's anonymous, it's only get, and we have this HTTP trigger here, which is anonymous also. So this is what is generated. We can access the code. We can't access the code, but we can test it like any other function here. We can select the method here, get the keys if we need to do that, and then we can run and test our function directly, even if it was developed locally. And here we have the response. So we need to pass the name, and we can also pass the name here. So to test it, we can run it directly. It's the same thing. We'll be doing the same. We'll be using the same function since the beginning, and you can get the function URL. It's the same thing here, and you can test it, and it's the same process. So those are one of the solutions to develop Azure Functions inside the portal directly or from Visual Studio. Or what we can do also is using the function CLI. So we need to install the function CLI. Then if we have already did that, so we can use the func directly to create, to initialize, or to start simply a function locally. What we can do here via the function CLI, after installing the function CLI, is, for example, here, let me go to here. Oh, sorry. Here, and what we can do here is find, for example, initialize or create our function, and then we can also add the name of our function app. Here we need to select the runtime also, .NET, Node, Python, or PowerShell, and select .NET directly, and then the function CLI will create the files and the dependencies that we need in order to develop our function. What we have here, if we need to access directly here, so here we have the folder function. Inside this folder we have our function app, Reactor app, and here we have the basic basic files like the csproj and the host, the JSON that defines our environment here that we need to develop. And here we have nothing, but if we have a function, or we added the function, what we can do is func start here to start our function. But here, sorry, we need to access the Reactor app, and then func start directly to start here. But here we have nothing. We'll start the instance, but will not detect any function inside this project. We detect that we have the environment, we have declaration of what we need inside the host.json, but we don't have any functions right here. But we can add it, and we can update it later. So we can use Visual Studio, we can use Visual Studio Code, we can use any other even text editor, and then we can use directly the function CLI. What we can do also, so we talked about functions, but we talked also about the durable functions, or the orchestration of the functions. What we can do is develop also this type of function using the extension of this function. What we can do is the same. So here we can add another function via Visual Studio, and here we select Azure Function, And here at the bottom we have durable functions orchestration, and we have simple use of this extension. So here we have function of everything here. What we can do here is just delete this one. Don't need this one anymore. So here in the example is the first scenario is the chaining. So it's this one. Sorry, so it's this one, but in our case we have only three functions, and the output is a simple string, simple text that we can have as an output later. So here, let's view what we have. So here we have three functions and three types of functions. We have here the orchestrator that will handle the function, how we need to use those functions, the order, etc. And then we have here say hello, function to hello. Here is our function that will do something, literally. So we'll use the same function 3 times. And the last function is the HTTP start. It's the entry point for our function process, and the entry point will use, of course, our orchestrator. So here, what we have in our orchestrator is the execution of our function, say hello 3 times, and we have Tokyo, Seattle, and London here as an input, and the function will return hello. The name is the same function that we used before. And at the end, we'll have an output, a table that contains 3 strings: hello Tokyo, hello Seattle, hello London. So we can use, and we can also run the durable function here, or the orchestrator, directly from our machine locally to see what we have, and then in the second step, we'll also deploy this function to Azure also. So here, same thing. Here, the runtime detects that we have one function as an entry point, which is HTTP start. We can use this as an entry point. And here, it's not the output that we need. Why? Because we're using the extension, the durable function. Here, it's an orchestrator that will use the functions that will create one or many instances of one or many functions, and it will manage it. So here, when we use the HTTP start function, HTTP start, we have status query get URI. So here, to get the output, we need to use this link, or what you call also the instance ID. Here, we can use this link, and here we can have our output. So the output contains the instance ID, the status. So that's why we're using the orchestrator or the durable functions. And we have, of course, our output, which is a table, and it's the result of executing the functions 3 times: hello Tokyo, hello Seattle, and hello London. So this is a sample example, but like I said, we have many scenarios, many patterns, from the fan out, fan in to the async HTTP API, etc. So we have a lot of examples and a lot of patterns. So the same thing for here, the Reactor function. We'll deploy this function. We'll deploy or publish these functions directly, and you'll use the same functions. And here we'll see what will we have inside Azure. So here we have this function, only this one is the same thing. So here we'll deploy the function. Here we're using the durable functions extension. We said that we have 3 functions. We have 3 declarations here. We have function 2, the orchestrator. We have say hello, our function, or our logic, if we can say that. And we have the HTTP start. So we have 3, and we'll have 3 functions deployed or published here directly with one entry point, which is the HTTP start that we need to use in order to get our output. So here we have all of this. We have the orchestration, we have the activity or the functions or our logic also, and we have the HTTP start, which is the entry point of our workflow here. So we can use it and we can test HTTP start directly. The same thing, we can test it here from our portal directly, and we can have also the same output here. We need to use this link to get our output directly. So here we have our output: hello Tokyo, hello Seattle, and hello London. So this was Azure Functions and Durable Functions. Let me check the Q&A. Sorry, I didn't check the Q&A. Can we host Azure Function on the Library? If it's supported the installation of Azure Function runtime, so we have the what we call the Azure Function host here. So just to reply to Ahmed, we can deploy the function host. We can use it directly in Azure. We can deploy it anywhere, so our machine, our server, locally on or on another platform or cloud platform. Also, we can use that. Amadosi, can you share more details about cross-function communication queues? So it's the same thing. If you need to have communication between functions, so we can use the queues like any other applications. In this case, it's a function, or we can use like we saw the last part, the durable functions. I mean, how the communication works between the trigger and the function. It passes through the internet or MS backbone. So we're using Azure Services directly, and it will be on the Azure or MS backbone for the trigger and for the communication between. Of course, I mean the Azure Services. I don't mean HTTP. Depends. Like for us, it was via internet. Is there another question from me? Is there an isolated plan if the app service is inside an app service environment? Yes, we can have the same thing as the app service or as the web app via, for example, the premium plan that I mentioned at the beginning also. How do we, Cynthia, how do you follow TDD approach for Azure Functions? Is the same as the other applications. It's the same. It's the same thing, the same development, and for testing or for developing also, we can have the same logic, the business logic, and we have also the test, etc. Because it's based, for example, for .NET on the packages, we can use the NuGet packages, our NuGet packages, and we can have that also. So it's the same thing as the other application, but it's just the host which is new, which is Azure Functions. Ahmed, can any sort of triggers be setting Azure function? I don't know what you mean exactly. Can any sort of triggers setting Azure functions? So there we can use only the triggers that are developed or that are integrated directly, and that we have what we have currently inside Azure Functions. But we can use the, of course, HTTP if we need to integrate it with our applications the easiest way. Hamad, can the settings be customized of the function before? Yes. We have the same thing as the web app inside Azure. We have, let me just show you, sorry. So here, for the Azure Functions, we have the application settings part, or here the configuration, and here inside the configuration we have the application settings, and we have the connection string also. We can So we need to use this, which is the link with the application insights and definition of the function extension, etc. But we can use also, we can add our application settings if we need to do that. We can add it directly here, or from the file. Also on local we can have it and push it directly to Azure and override the things that already exists. I mean, can we adopt the blue-green deployment? I mean, deployment in stage slot. Yes, it's the same approach as the web apps also. Here we have the deployment slots, and we can create the slots directly here. So we can have many slots, and then we can test it, and we can have the same thing also. Hi, which VS extension you're using? Yeah, to use with Visual Studio. So here in the Visual Studio installer, we can see here what we need to install is the Azure tools here. Just wait here. Sorry. So here we need to install the Azure development tools here, and the Azure development tools contain the Azure Functions runtime, or we can also search here Azure Functions runtime directly. For information, Azure Functions runtime and also the host are open source and are on GitHub. Directly we can use it, and you can see what we have directly. What you have directly here. So if you want to take a look at that and to install it simply without installing all the Azure development tools on your local machine. Azure function additional resource for reading link. Yes. Here, so we have the documentation, so docs.microsoft.com, and on the docs.microsoft.com we have the Azure part, and on the Azure part we can find here Azure Functions, and we have everything related to Azure Functions, from the overview to creating our first functions here to developing to learn, and all the links are here. Let me just here Azure Functions. On the chat window, I send that on the chat window. We have also Microsoft Learn. We have a lot of learning paths. So here we have a lot of learning paths or modules, and if you search here functions, we'll have a lot of modules and learning paths. For example, here this one is very good learning path. It's all about create services application in general, and we have also the Azure Functions here with many use cases. Siad, for queue, can you use Microsoft Queue or any other queue? So the integrated ones are directly what we have, so service bus queue or storage queue. But if you want to use your queue, so it will be inside the code directory or via the HTTP triggers also. So I think I answered all the questions.
Thank you.
Hussam, can you please confirm? I think I answered all the questions.
Yes, it's all good. I'll take over the presentation. All right, a few things that I want to share with the community members. First of all, A quick reminder about taking the Reactor survey. This helps us understand more about the content and the topics that you would like to see in future sessions in the Reactor. Please use the event code while taking the survey for today's session. And I want to also share with you a few upcoming sessions that are happening this week. So tomorrow there is a session on the building blocks of HTML and CSS. If you're interested in developing your own website or someone you know, the first step is to learn the core components about displaying information in a browser. So this hands-on workshops, we will be using HTML tags and identifying different sections of a page, allowing user to enter information, and then we will experiment with the CSS to showcase how to format and style the page. So in this workshop, we'll be writing code using VS Code, and you can share it as well within your network for those who are interested in getting started with HTML and CSS. And on Wednesday, there is a session on Go. So Go is becoming a very hot language for low-level systems development, databases, and distributed systems. And also this language has expanded to be beyond just system development. So if you heard of Docker, Kubernetes, they're all written in Go. You can even build full web apps with Go. And in this session, we'll briefly go over the history of Go and dive into the language and the libraries and the different web services. And finally, we'll build a REST API using the Go and deploy it to the web and test it. And on Thursday, there is a session on Azure API exploration. Azure APIs can help you create continuous integration, simplify authentication, and provide on-premises connectivity. And in this session, we will explore various options as Sarah Goethals discovers, creates, and likely fails at using Azure APIs. So join us. There are also more learning opportunities for you on our page on meetup.com. And also for you to continue the journey, you can sign up to our Reactor newsletter, check out the upcoming sessions. We send out a monthly curated newsletter. And also you can subscribe to the Azure developer community and also check the Cloud Society for more learning opportunities. I'd like to thank you again for being part of our community, and we're about to reach 2,000 members of Meetup. I'd love to encourage you to share the Meetup page and the upcoming sessions with your friends. Stay safe, everyone, and hope to see you soon in upcoming sessions.
Thank you, Hussein. Thank you all. See you soon.